Morning students, next today's topic is polynomials. In polynomials we have also some important sums on 2 marks and 1 mark questions. So first of all, let us see the quick revision of the polynomials concepts. So first of all, what is meant by a polynomial? A polynomial is a algebraic expression in which involves variables with positive integral powers. So here, for example, I am writing a polynomial. It is denoted by p of x. That is, I am writing one general form of polynomial 3x cube minus 2x square plus 4x plus 1. This is an expression in which the variables are involved and with the integral powers of positive integral powers, which involves with the positive integral powers. Okay, which is a polynomial. So the general form of the polynomial, we can write it as a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 up to so on an. So here a0, a1, a2 are the real numbers and here x is a variable and the exponents must be non-negative integral powers, non-negative integrals. So it is that powers must be what? Non-negative integrals. That means they are always a positive numbers, positive integers. Okay. So here 3, 2, 1, these are all what? Positive integers. Okay. If for suppose if you have 4x to the power of minus 1 by 2 plus 2x power minus 1 or p root x, like these expressions are not a polynomials. Okay? These are only multinomials. Just we take this expression as the terms more than 2. So that's not a polynomial. Polynomial means, especially in polynomial, a variable is exist and its powers must be the positive integers, that is non-negative integrals. Okay, so this is a polynomial definition. And next, depending upon the number of terms, we can define the types of polynomials. If a polynomial has only one term, that is known as a monopolynomial. If it has only 2 terms, it is binomial. If it is 3 terms, it is known as a trinomial. And if it has more than 3, it is known as a monomial, multinomial. So here, depending upon the degree also, we can define the types of the polynomial. If the polynomial degree is 0, that is should be a constant. And if the polynomial degree is 1, that is a linear polynomial. For example, 3x plus 2 is a linear polynomial. And next, if it has the degree 2, 3x square plus 4x plus 6, it is a degree 2, which is known as a quadratic polynomial. And if its degree is 4, for example 4, then that polynomial is said to be biquadratic polynomial. So like this, depending upon the degree also, we can define the types of polynomials. So whereas especially in this class we have only the quadratic polynomial concept and the cubic polynomial concept. If the degree is 3, then it is known as a cubic polynomial. So now here, for example, I am taking one polynomial ax square plus bx plus c. Okay. Here it is a quadratic polynomial. Why it is so called by quadratic polynomial? The degree is 2. Its degree is 2. That's why it is known as a quadratic polynomial. So depending upon the degree, we can say the number of zeros. That means the number of solutions of that polynomial. It means ax square plus bx plus c equal to 0 for a particular values of x. Then the values are known as the zeros of that given quadratic polynomial. So here, for example, alpha and beta are the zeros of that polynomial. Then we can write that x is equal to alpha and x is equal to beta. Here we can write it as x minus alpha into x minus beta. That maybe some, you can take some constant multiple k. Now here by multiplying this we get x square minus of alpha plus beta into x plus alpha beta. Okay. Now here also ax square plus bx plus c, this also we can write in this form. So by taking a common we get x square plus bx by a plus c by a. So then here we get by comparison of both the sides we get alpha plus beta is equal to minus of alpha plus beta is equal to b by a. Therefore alpha plus beta is simply minus b by a, and alpha into beta is equal to simply c by a. Okay. Here we can compare the a value a. So with respect to that, we mainly concentrate on this alpha plus beta and alpha into beta, that is sum of the zeros and product of the zeros. So we will ask the questions on this sum of the zeros and the product of the zeros. So that means ax square plus bx plus c is the quadratic polynomial. If it has two zeros, it may be alpha and beta. Let us suppose x is equal to alpha and x is equal to beta. Then x minus alpha, x minus beta are becomes factors of that particular polynomial. Then whenever you product these two, that must be equal to the ax square plus bx plus c type of quadratic polynomial. So if you know the alpha and beta, that means zeros of that particular polynomial, you can write that quadratic polynomial in this way: a times of x square minus alpha plus beta into x plus alpha beta. Sometimes they lost the sum of the zeros or sum of the product of the zeros of the sides given polynomial, or they lost the relation between the zeros of the polynomial and the coefficients of the given polynomial. So like this they will ask the questions on this. And next, for example, I am taking a cubic polynomial. So in cubic polynomial there also you can write like this: cubic polynomial, that is ax cube plus bx square plus cx plus d. Here let us suppose alpha, beta, gamma be the zeros of this particular polynomial. Then we can write here the zeros are x is equal to alpha, x is equal to beta, and x is equal to gamma. Why? Because here the degree is 3, so it must contain some 3 zeros. So here we can write in this type x minus alpha into x minus beta into x minus gamma. Okay. After multiplying this, we may get like this: x cube minus alpha plus beta plus gamma into x square plus alpha beta plus beta gamma plus gamma alpha into x lost minus alpha beta gamma. So no need to verify or no need to write this polynomial. So simply just by multiplication x minus alpha, x minus beta, x minus gamma step by step, we will get the final answer: x cube minus alpha plus beta plus gamma into x square plus alpha beta plus beta gamma plus gamma alpha into x minus alpha beta gamma. That is, here we can remember formulas like this: sum of the zeros alpha plus beta plus gamma. Okay, before I did not, so take this polynomial again in the comparison, take the a common from all this, so we get x cube plus b by a x square plus c by a x plus d by a. So whenever d by a, so whenever you take common a from all this, so you just put like this type of equation. So here x cube and here is also x cube. So we got alpha plus beta plus gamma, that is minus of alpha plus beta plus gamma is b by a. Then the sum of the zeros alpha plus beta plus gamma equal to minus b by a. This is the first formula. And the second is alpha beta plus beta gamma plus gamma alpha is c by a. And last alpha beta gamma is actually minus there. Then by transferring that side we get simply minus b by a. So like this we can easily remember these formulas. Okay. So by using these formulas, we can find the relation between the zeros of the polynomial and the coefficients of the given cubic polynomial. Okay. And next we will ask the questions on solving the zeros of the given polynomial or given quadratic polynomial. Let us take one example, that one. So here the first question for 2 marks or 1 mark, they will ask like this: check whether minus 2 and plus 2 are the zeros of the polynomial. Zeros of the polynomial x square x power 4 minus 16. So first of all, let us take as p of x is equal to x power 4 minus 16. So put x is equal to minus 2. Then we get p of minus 2 equal to, simply substitute in place of x minus 2. Minus 2 to the power of 4 minus 16. Minus 2 to the power of 4 means 16. 16 minus 16 we get 0. So next, put x is equal to 2. So p of 2 is equal to, we can write it as 2 power 4 minus 16. That is 16 minus 16, 0. So whenever you get the zeros, that means these 2 minus 2 and plus 2 are satisfies the equation. Therefore, yes, minus 2 and plus 2 are the zeros of the polynomial. So here we can write minus 2 and 2 are the zeros of polynomial. Okay, if you get 0 by substituting the x value, given x value, if you get 0, then that value is known as the zero of the polynomial. So next they will ask, check whether the given zeros 3 and minus 2 are the zeros of the polynomial c of x is equal to x square minus x minus 6. Now we also let us assume it as p of x. Simply x square minus x minus 6. Substitute it. Put x is equal to 3. Now we can write p of 3 equal to 3 square minus 3 minus 6. 3 square is 9. Minus 3 minus 6 is minus 9. 9 minus 9 is 0. Next, put x is equal to minus 2. P of minus 2 equal to minus 2 square. Minus of minus 2 minus 6. Minus 2 square is 4. Minus of minus plus 2 minus 6. 6 minus 6, 0. So therefore we can say 3 minus 2 are the zeros of p of x, that is x square minus x minus 6. So like this, let us check whether the given zeros are zeros of the given polynomial or not. So like this some they will ask. And one more type also they will ask. Here, find the zeros of the quadratic polynomial and find the zeros of quadratic polynomial, given quadratic polynomial, and verify the relation. Relation between the zeros and their coefficients. Between zeros and coefficients. So for example, I am taking one polynomial, that is x square minus 3x minus 8. So first of all, let us take the splitting middle term method. So here first of all multiply first and last terms. So x square into minus 8 minus 8x square. So middle we have minus 2x. We have to split minus 2x by using the factors of 8. 8 factors are simply you can take 2 4s are 4 2s are. So one writer not satisfies that minus 2x to split that one. So 2 and 4 are the very suitable. So take the 4 and the 2 like this. So keep here minus 4 and here plus 2. Why? We have to get minus 2. Minus 4 plus 2 minus 2. So here we particularly get minus 2x minus 4x plus 2x. So we can write it as x square minus 4x plus 2x minus 8. So x square nothing but x into x minus 4 into x plus 2 into x minus 2 into 4. Now take x common these two. X times of x minus 4 plus 2 times of x minus 4. So we can write x minus 4 into x plus 2. Here the 1 0 is x minus 4 equal to 0, that is x is equal to 4. Let it be alpha. And the next is x plus 2 equal to 0, x is equal to minus 2, that is beta. Now the verification. Okay, sum of the zeros, that is alpha plus beta. So add them simply 4 plus of minus 2, that is 2. Actual formula alpha plus beta equal to what? Minus b by a, that is x quotient by x square quotient minus quotient of x by quotient of x square. That is here alpha plus beta equal to quotient of x is here minus 2. So already minus is plus minus 2. Quotient of x square is 1. So minus of 1 is 2. Minus of 1 is plus into 2. 2 by 1 is 2. So it is verified. Next alpha into beta. Alpha into beta is there simply 4 into minus 2. 4 into minus 2 minus 8. And here the relation is c by a, it is constant by quotient of x square. Constant term by quotient of x square. That is, we can write it as alpha into beta equal to c by a, that is minus 8 by 1. So alpha into beta equal to minus 8. So hence these two are verified. You can write it as verified. So like this we will ask these type of questions. Okay. And next, if alpha and beta are given, if two zeros are given, we will ask find quadratic polynomial. For example, if alpha is 2, beta is minus 1, if zeros of polynomial. Otherwise, if zeros of polynomial 2 and minus 3, then find the quadratic polynomial. So here the formula is simply we can write p of x is equal to some k into x square minus alpha plus beta into x plus alpha beta. So alpha value is 2, beta is minus 3. Find alpha plus beta, that is 2 minus 3 minus 1. Alpha into beta 2 into minus 3 minus 6. Then a into x square minus of minus 1 into x plus of minus 6. So we can write it as x square plus x minus 6. So let us assume here k is equal to 1. If let k is equal to 1 is enough, so we can write it as x square plus x minus 6. So like this we can find the quadratic polynomial when the zeros are given. Okay. sometimes they will give sum of the zeros and the product of the zeros. Then they will ask find the polynomial. So in that case also we have some important terms. For example, if sum of the zeros are 1 by 4 and product of 0 is minus 1. If sum of zeros is minus 1 by 4 and the product is 1, then find quadratic polynomial. So here the direct formula is x square minus a into x square minus alpha plus beta into x plus alpha beta. Substitute the sum of the zeros, alpha plus beta minus 1 by 4, alpha beta is 1. So you can write it as a into x square minus 1 by 4 into x plus 1. So a into, you can write it as minus or minus plus 1 by 4 into x plus. So on multiplication you get 4x square plus x plus 1 by 4. So let us take a is equal to 4, then 4 will get cancelled. That is, let it as 4x square plus x plus 1 by 4 into 4x square plus x plus 1 by 4 gets cancelled. The final answer is 4x square plus x plus 4. So like this they lost the polynomial with the sum and the product is given. Now here and these are the very important sums, and sometimes they will ask the sum and product of the non-cubic polynomial also they will ask. Verify that 1 minus 1 and minus 3. 1 minus 1 and minus 3 are the zeros of cubic polynomial. X cube plus 3x square minus 1x minus 3, and also verify the relation, and also verify the relation between the zeros and quotients. Between the zeros and the quotients. So here first of all let us take it as p of x cube plus 3x square minus x minus 3. So put x is equal to 1. It is p of 1. Then 1 cube plus 3 into 1 square minus 1 minus 3. So we can write it as 1 plus 3 minus 1 minus 3 plus 1 minus 2 cancel, 3 minus 8 is 0. So then the first one is the 0 of the polynomial. Next, put x is equal to minus 1. Then p of minus 1 equal to minus 1 cube plus 3 into minus 1 square minus of minus 1 minus 3. That is minus 1 plus 3 into minus 1 square is 3 only, 3 into 1 1 plus 1 minus 1. And also minus 1 plus 1, 3 minus 3 cancel 0. And again put x is equal to minus 3. So p of minus 3 equal to minus 3 cube plus 3 into minus 3 square minus of minus 3 minus 3. Minus 3 cube is minus 27 plus 3 into 9 plus 3 minus 3. So minus 27 plus 27. 3 minus 3 0. Here also 0. So minus 3 also 0 to 1. Hence verified. Now relation. So in the relation we have the 3 formulas. So what are they here? First one, alpha plus beta plus gamma. That is, the first root is taken as 1. Alpha is equal to 1. Second root of 0 is beta minus 1. Gamma minus 3. Alpha plus beta plus 1. 1 plus of minus 1 plus of minus 3. 1 minus 1 0 minus 3 minus 3. Now again here we have the formula alpha plus beta plus gamma minus of coefficient of x square by coefficient of x cube. It is simply you can write minus b by a. It is minus of b is here. 3 is equal to 1. So here we can write that is minus in the formula minus 3 by 1. So simply we can write minus 3, hence del phi. And again alpha into beta plus beta into gamma plus gamma into alpha. Okay. So here alpha into beta is 1 into minus 1 plus beta into gamma is minus 1 into 3 plus gamma into alpha is minus 3 into 1. So minus 1 minus 3 minus 3. That is simply we get here minus 7. Sorry. So find the beta 1 into minus 1. Minus 1 is minus 3 this one. So plus 3. So plus 3 minus 3 gets cancelled, we get minus 1. Now here alpha beta gamma alpha. That is, we have simply c by e. That is coefficient of x cubed by coefficient of x by coefficient of x cubed. That is simply c by a, that is minus 1 by 9. That is minus 1. Okay. The last is alpha into beta into gamma. Alpha into beta into gamma. Alpha into beta into gamma. That is 1 into minus 1 into minus 3. Simply 3. Now formula alpha into beta into gamma is minus a by e. That is minus constant term by coefficient of x cube. So we can write it as minus, already minus is there, so here a value minus 3. So that's why a value 1. So 3. So hence we can verify the relations. So like this we can do the two more sums in polynomial. Let us see in the next video.